So before I begin this tutorial, I just wanted to say that everything that I'm going to talk about in this video is solely my opinion. And this will be a very subjective video. And if you ask 10 programmers what they think about, a certain technology, you're going to get 10 different answers. Because if you think about it, opinions are very important for the progress of software development. If you look at these three guys, these are some of the top software development guys in our industry, right? The guy that created Linux, the guy that created Microsoft, and the guy that created Apple. These are the best of the best, right? And they were so opinionated that they created their own operating systems, right? That's how opinionated they were. And they all had like different takes on it, right? Yet each one is being used in our industry. And I guess that's what my point is, especially the message that I'm trying to come across in my channel. Don't be afraid to tell people, especially employers or whatever, like tell them your opinions exactly. Be as specific as you want, and the more unique your opinions are, the better. That's really the only way to get ahead. If you start following people, I see this a lot. People are just following certain technologies, certain frameworks, certain ways of thinking. It's just you're not going to be unique that way. You're not going to create. You're not going to innovate in that way. So just make sure that you have your own voice. That's the most important thing. So I wanted to talk about object-oriented programming, especially statically typed object-oriented programming, and I'll get into what that all means in a bit. But basically the creation of types, okay, the creation of components, it's really an important thing to understand, because once you understand that, you can understand how all of programming works, because our whole industry is kind of revolving around this concept, okay? All of the languages use this concept. There's a lot of different frameworks and different technologies out there that try to get you to work in this way. And so I'm going to give you a completely different perspective on why I think that I don't like this. I mean, I don't like these technologies. A lot of the times we hear just one side of the programming world, and they teach you how to do something, and to me, it's all a waste of time. I guess what I wanted to talk about in this video is how OOP and types is essentially like Shakespeare. Okay, so why are we talking about Shakespeare? What does he have anything to do with programming languages? Well, this guy is the GOAT of the English language, the greatest of all time. He invented, well, some say that he invented around 1,700 words. There's some debate on that, but basically, let's just say that this guy invented a ton of words. I'll show you a few. Okay, so here are some of the words that he invented: lonely, bedroom, critic, gloomy, excitement, and thousands of other words that we use today without even thinking about it. But he was he was very good at words. And one thing that I want to emphasize is that if you ever read any kind of Shakespeare play, you will be using a dictionary to figure out what the heck this guy is talking about, because there's absolutely no way that anybody, unless you're some kind of English genius or something like that, can understand what he's talking about. I'll give you an example. See you now, your bait of falsehood takes this carp of truth, and thus do we of wisdom and of reach, with windlasses and with assays of bias, by indirections find directions out. Okay, what the heck does this mean, right? Like, you'd see all these, first of all, there's a lot of weird words like assays of bias, if I'm even pronouncing that right, windlasses. You'd have to know that carp is a type of fish. You'd have to understand that this is some kind of metaphor, that this sense is essentially I mean, there's just a lot of things that you'd have to figure out. And this is just one paragraph. I mean, the whole, if you ever read Hamlet, every single paragraph, you know, just check it out right now. You pull it up. You'll find that every single paragraph, you'll be like, what? What does this mean? Like, what is this paragraph? What does this word mean? And he'll have like thousands and thousands of words that you just don't know what they mean. And you have to look them up. And instead of writing it like this, right, I could have just written this paragraph like, you can use a lie to gain truth, like using bait to deceive and catch a fish, right? This would have been so much more straightforward, right, than using all of these different types of words. I could have used just plain English, but that wasn't Shakespeare. I mean, Shakespeare was a poet. He was an artist. But I guess what I'm getting to is that art is not very efficient in the business world anyway. If you want to, you know, in software is the bread and butter of the business world. I mean, if you want to, you know, do well in software, or at least make things efficient as you're writing software, it's all about dumbing things down. In my opinion anyway. See, a lot of the things that you'll learn about object-oriented programming was started in universities where they're more about, you know, theory than practicality. And practicality, in order to make things efficient, we really have to dumb things down. Now, I'll show you how in other languages, well, in programming languages, how we have a lot of these types of vocabulary that you can't just, you know, you can't just like read a paragraph of code and know what it means. You'd have to look up every single word, and that just takes a ton of time. It's kind of like reading a Shakespeare play. Here, let me show you the Shakespearean programming languages, aka object-oriented programming languages, that have a bunch of vocabulary and keywords and, you know, just a lot of syntax. And I just want to give you a few examples in a bunch of different languages. So first of all, when you look at languages like this, you know, this is going to be like Android, Java type development. And you'll see when you go through documentation for stuff like this, first thing you'll notice is that you just have a ton of different words, right? I need to know what a recycler view is. That's a view group, a layout manager, a linear layout manager, a grid layout manager. You know, I have to extend from this adapter. Just like a ton of, different vocabulary, right? Kind of like what we saw in Shakespeare. Now, I had this guy in the comment section, and he told me, if you're going to compare Swift to HTML, then you should compare Swift UI to HTML. You shouldn't compare the actual Swift code to HTML, because obviously HTML is going to be easier. I thought about it, and it's like, I mean, Swift UI doesn't make anything easier, you know? Like, well, at least in my opinion, I mean, it's just more... Like, look at this, for example. So now this is Swift's new way of creating user interfaces, right? They call it Swift UI. But again, it's just more vocabulary. You know, I have to know what a VStack is, what a map view, a circle image, VStack, text, just all this stuff, right? Who has time to like figure all that? I mean, it's just not important for UI. I mean, I don't know. Just in my opinion, okay, it's just not that important. Let's look at XAML and C# WPF. Remember how, and again, most languages, right, they'll have like the declarative part for the UI, kind of like HTML, right? And then they'll have the programming part, which is kind of like JavaScript, right? This is C#. But I just want to show you like two different examples on how, like, don't even worry about what this code does, but just look at all the stuff that's like in green, okay? Those are all the words that, all the vocabulary words that we must know in order to use this thing, right? And that's where I disagree. It's like, why put people through all that? Why do you need all this stuff? It's just, having a component should be the exception, not the rule. Okay, 95% of the code should just be, as I said, divs in my other videos. But I'll show you what I mean in a bit. But even let's look at the C# aspect of it. It's just a lot of different vocabulary, right? You'd have to know what a storyboard is. You'd have to, well, I mean, this is like a new button, a new solid color, like everything is syntax, everything is vocabulary. And again, that is due to statically typed object-oriented programming. Let's look at the most popular programming languages in 2022. Okay, do you think that it's a coincidence that JavaScript and Python are #1? Okay, the dynamically typed languages that don't require you to, to use all this crazy syntax that all these other older languages did. Or not just older languages, TypeScript does this too. But all these languages like TypeScript, Java, C#, C++, and on, that are statically typed. Okay, do you know what statically typed versus dynamically typed is? Let me show you an example because it's super important. So the first language we'll look at is Java, and this is a statically typed programming language. And if you look at the definition between dynamic and statically typed, a lot of people will say, they'll give you like a cryptic definition, like the types must be declared at compile time in a statically typed language. But I mean, when people say compile time, it just, don't even think about it that way. Just think about it that the source code itself, see the source code? Okay, you're going to see types everywhere in a statically typed language. So for example, and why do I, say that object-oriented programming is essentially like Shakespeare, is because when I define classes in an object-oriented programming language, see how I define dog and robot here? They will now become a part of the vocabulary of the language, meaning you'll start seeing them all over the source code. Okay, so for example, see this function here called test? So see how I have this dog that I pass into test. I had to explicitly say that it is of type dog, okay, in order for this function to work. And that's what a statically typed language is. You have to explicitly state what types of variables you're using, especially when you call them in like functions and stuff like that, like in the function parameters. So even if you had some kind of like generic object, you still have to say that it is of type object. And then if you were to use it inside the function, you'd still have to explicitly typecast it to whatever you're using. So I know that sounds kind of complicated, but basically just note that in the source code itself, the class robot now became a part of the vocabulary of my source code. See how like I use it here everywhere, robot and dog here, and how I declare it. I essentially created a new type. And the ramifications of this is that, let me show you a few examples. This is in C#, okay? What the ramifications of this is that you're going to see these types everywhere. See, like for example, when I pass in, something to like a function, I have to explicitly say what the types are and all the parameters. And what this causes is a huge bloated mess, in my opinion. Like it just, you increase the vocabulary of the source code. Now you have more syntax. Okay, I'll give you another example. Okay, this is Swift. And basically see how, again, you have all these parameters that I must explicitly state what type it is. See, now this is of type string, this is of type UI image, and everywhere where I use these variables, I'm going to also have to, declare what type they are, and so on and so forth. But basically, just think about it this way. Like in statically typed languages, you increase the vocabulary. You have now more vocabulary words that you have to deal with. Kind of like in Shakespeare plays where you have just a ton of different words that you must figure out in order to understand it. So let's look at a dynamically typed programming language. This is JavaScript. And the first thing you'll notice is that in the functions themselves, I don't have to have types for the parameters. So like if this was Java or C#, I'd have like, you know, the type. A robot, a dog, if it's an integer, a string, whatever. I don't have that. I also don't have the return types or the access modifiers. Like in Java and C#, you'd have like public, int, whatever. Like if it returns an int, or that if it's public or private. You don't have all that crap in JavaScript. It's very simple. Okay. Just note, I mean, you don't have to know what all this stuff means, but just note for now that in dynamic languages, the syntax is much less. And I'm all about less is more. Basically, I like minimalism. I think, you know, things are way too explicit in those statically typed languages, and it takes forever to do anything with them because you have so much stuff to write. Let's look at another language like Python. And you'll notice again, when I have a function, I don't need to declare a type for these functions. Okay. Same with the constructors of these classes. I didn't have to declare if it's an int or a string. It infers it by itself because it's a dynamic language. So let me show you another example. This is XML on the left side, and this is JSON on the right side. In statically typed languages, generally would use XML back in the day, although now they're shifting more towards JSON, which is kind of funny because JSON means JavaScript object notation. So anyway, I won't get into that, but basically just note that the XML is essentially, see how like we have to declare the types for everything, right? And all of these were essentially created with classes. So you could just imagine how bloated up the source code would be. But here, there is no types. See? I don't have any types. I just have, I mean, I might have the name of the variable, but that's not a type because you could have put in any type of content in here. It's almost like JSON, you could think about it as a dynamic language and XML as a statically typed language. And this thing wasted so much of my time, and that's why I created this channel, just because of this and how I don't think that these types are very efficient anymore to create source code. It's just, it wastes too much time. Now, one of the things that you'll notice is that the newer languages or the newer frameworks like React and so forth, they're trying to bring back types. Okay, so you'll see that a lot of the stuff that they do in UI, for example, where they create components, is essentially this. They're trying to bring back XML. And I don't want that at all. I want everything to just be divs. I don't want, I just want hierarchies of divs, just like hierarchies of JSON. I don't want hierarchies of types. It's unneeded. It's not important. Similarly, if we look at, you know, HTML, basically a lot of the newer frameworks are telling you to use components. Okay, so like basically you'll, like, let's say we're talking about a calculator, then you'll see a new component called, a new web component called calculator display, calculator key, or whatever they decide a new type should be. Whereas the way I like to code, I'll only have divs. Okay, I don't want any new types of components. I don't want something where all of a sudden some new type of component has a different way to interface with it. I want all of the things on my screen to have the exact same way, the exact same you know, parameters. I don't want the moment you have a lot of different components, each one has its own parameters. Now, it might not look like a big deal for something like this, but trust me, when you have thousands, but like hundreds of screens and they all have different components, it gets a lot harder. Now, if you still don't believe me, then go ahead and do the component thing for 10 years. And when you're sick of that, come back to my channel. Now, what if some of these divs are actually the same? Like, let's say, for example, we have a bunch of divs that will have the same content. Like maybe they share the same type of graph control or something. Well, in that case, I'll give them the same class, and then I'll just iterate through them in JavaScript and then create them in JavaScript. Meaning JavaScript will take care of things that are the same. It's just the same function essentially. But yeah, I don't want the whole component thing, personally. Now, am I saying that 100% of your program should just be divs? No, but like the vast majority. Okay, I mean, obviously you might have some, situations where you have a canvas, SVG, some type of component, even a custom component that you write. Sure, I mean, once in a while, maybe it would be beneficial to create a web component. But again, the vast majority could just be these typeless containers, and that's my main argument. If you go to any one of these newer frameworks, they'll convince you that everything needs to be a component, and I'm telling you that just wastes a lot of time. Let me show you another last example here. On the left, you'll see some Shakespeare paragraphs of some stuff from his plays, but basically you'll notice that he uses a ton of vocabulary words. Okay, like when you read his stuff, you'll have to use a dictionary to understand what he's talking about. A lot of his plays are like this. He was obsessed with words and complicated words at that. And it always reminded me of statically typed languages, or even not statically typed languages, but just like languages that define types or components or whatever. Languages that define vocabulary are like this. You'll look at the source code of these languages. This is an example in C#, but you'll start seeing a lot of different words that you may or may not be familiar with. You'll have to understand how to use each and every one. As opposed to what I'm proposing, which is basically don't have any types. Just have containers. That's all you need. In UI, we'll have hierarchies of divs. And in code, we'll have var. And maybe those vars, they might contain different things like objects, primitives, and so forth. But we're not going to define any types. And this will make the source code first of all, it'll be a lot less words. It'll be smaller. It'll be kind of like the difference between JSON and XML. On one side, you have a lot of different words, a lot of different types. And on the other hand, you just have containers. And that's the way, well, for me anyway, that's the way forward. It should just be about containers. It should not be about types and vocabulary words, and all that stuff leads to higher development times. Now, I just want to give you just something to remember. Basically kind of like homework, but it's not really going to be homework because it's going to be way easier than that. But just as you interact with screens, kiosks, whatever, during your life, maybe you'll go to the ATM machine, maybe you'll check something out at the supermarket, maybe you'll use some kind of app or whatever. Just notice, okay, I just want you to notice how 95% of the apps that you're interacting with, they're essentially just panels. Okay, maybe they have some pictures in them, but they're essentially just panels, hierarchies of panels. I don't even know why programmers decided to come up with this idea that we have to have types for everything. See, people made programming harder than it's supposed to be. What you're dealing with most of the time in these languages, what you're struggling with is types and vocabulary and really weird syntax. Get rid of the syntax, and I promise you, programming is very easy, because what we're trying to achieve is essentially just laying out these panels that have events on them. And that's it. It's very simple. Anyway, I'll show you demos in the future of how I code, and this will all make way more sense. Thanks for watching.